And from now on, let's double click TechWiz LCD 1D. TechWiz LCD 1D window appears. The materials saved in TechWiz DB are displayed in DB Explorer as a list form. And if you double click the particular material, you can check the DB information. And the material can be easily inserted into the stack list by drag and drop method. For example, like this. Or utilize these icons such as add, delete, delete all, and so on. To design the cell structure, just stack up the layers from bottom to top or from top to bottom. And there is a properties window. You can define the properties of each layer. And in the output, the status of the simulation can be checked. And on the top, there are a main menu and a toolbar which can set the options for the project file or simulation. You can create a new project file or load the previous saved project file or save this current project file. Also, you can select a solver to analyze the LC distribution or choose an optical analysis method. I will talk about it later on in detail. And if you click this Run button, the simulation starts. And there is an option. You can set a lot of options like this. However, in this training, I will not mention about them. So if you are interested in these options, please refer to the manual. So far, we have looked at the big items of TechWiz 1D program. Let's design the TN example together and I will explain the specific functions. When you design the cell structure, the first thing to do is creating a new project. Click this New button or click File and select New. Enter the name of a project and set the saved path. When checking Create Project Folder, the same folder as the project name is created and the project file is saved in that folder. I will check it and enter the name as EX. And then I will save it to the desktop. Please click OK button. As you can see, the path of the project file and output file is specified. From now on, let's define the stack list with a simple TN example. Based on this figure, let's define the stack list. Please drag and drop the material of all layers to be used. I will define this structure from top to bottom. So the first one is polarizer. I will use this polarizer in the material DB. And then glass, ITO, PI, and for the LC, I will use this TNLC 30. If you use the same material, just copy and paste it. Press Ctrl C and Ctrl V. You can also insert the white sauce on the external top or bottom. There is a backlight unit on the external bottom part, so please go to the light source DB and select CCFL. So all of the layers are added into the stack list. At first, let's talk about the LC. You can check the properties of TNLC30 that we use. Also, important parts to set the LC properties are thickness, division, and rubbing condition. In this case, thickness means the cell gap. Please enter 3.5 micrometers. And then enter the number of divisions. Normally, about 21 is entered. However, in this case, to check the calculation results quickly, please enter 15. And let's set the rubbing condition. Pre-tilt and azimuthal mean theta and phi angles respectively. And let's enter a pre-tilt angle as 3 degrees. Assuming that the dark direction is 6 o'clock, the azimuthal angle of the bottom surface should be minus 45 degrees, and for the top surface should be minus 135 degrees. Therefore, it is a structure that is twisted by 90 degrees. And then let's take a look at the polarizers. There are a top polarizer and a bottom polarizer. You can check the properties as well. For polarizers, please pay attention to setting phi angle. I will set the phi angle of the polarizer based on the O mode. In the rubbing condition of liquid crystal, the bottom surface of azimuthal angle is minus 45 degrees. TechWiz program sets the absorption axis as the reference. Therefore, I will define the pi angle of the bottom polarizer as minus 45 degrees. One thing to keep in mind when setting the angle on TechWiz LCD is that it should always be defined in terms of extraordinary orientation. The larger of KE and KO is the reference for the absorption axis. Look at the K values of the polarizer. KE is larger than KO. You can also check minus 45 degrees is the absorption axis. As the same way, let's enter minus 135 degrees for the top polarizer. And for the thickness, it is essential to set the thickness according to the measured data. In the TechWiz DB, I mentioned that when you use the default polarizer in the material DB, I recommend to use 230 micrometers. And then let's go to the next layer, glass. Also, there is a top glass and a bottom glass. You can see the properties of the glass layer. And the thickness is 1 micrometer. But it is a default value, so let's move on to the next layer. There are ITO layers on top and bottom. Also, you can check the thickness, resistivity, and optical properties. Please change the thickness as 0.05 micrometers. The bottom ITO stays the same, so I will change it. In this time, I will modify the layer name. To change the layer name, right-click and select Rename, or just double-click it. For the top ITO layer, I will change it as COM, which means common electrode. And as the same way, I will change the layer name of the bottom ITO as Pixel. Moreover, for the metal layer, you can set the voltage condition. You can see that there are 5 types of voltage conditions. I will talk about it more detail. No bias means that it is a floating type, no voltage condition. DC is selected when a constant voltage is applied continuously from the start of the simulation until the end. And there is a sweep and sweep saturation. Method to set the voltage conditions is the same. By using comma or semicolon, multiple voltages can be applied. Also, when you want to define the voltage condition as a range, enter in the form of like this. However, here is the difference. When you use sweep, you should set the finite time and output additionally. Finite time is the last time the simulation ends, and output time is the output for the result. On the other hand, if you select sweep saturation, the solver judges the saturation automatically at the applied voltage condition. So, I recommend to use sweep saturation between the two, because it is easier to set the conditions. Lastly, if you select a pulse signal, you can use the signal dB predefined in TechWiz DB, or use the signal as a voltage condition by setting values. In this example, the common electrode is defined as DC 0 volts, and the pixel electrode should be applied with a voltage from 0 to 5 volts at 0.2 volts intervals. So for the common electrode, I will use it as default, and for the pixel electrode, I will change it as sweep saturation, and I will set the range like this. And the next one is PI. Also, the PI layers consist of a pair. The thickness is 0.08 micrometers respectively. So I will change it as 0.08. Also, you can check the electrical and optical properties as well. Lastly, let's set the conditions for the light source. The first one is attachment function. It is used to set whether the BLU is attached to the panel or not. If you select yes, BLU is attached to the panel. So the transmittance is the same for the viewing angle. Otherwise, if you select no, BLU is not attached to the panel, so the transmittance can be changed for the viewing angles. And the next one is optical properties. You can set the refractive index between BLU and panel. In case of air, refractive index is 1. And the following ones are setting for the wavelengths and viewing angle. It is the same as the method set in the voltage condition. Multiple values can be applied using comma and semicolon. When you want to define it as a range, please enter in the form of like this. So in this training, for the wavelengths condition, please select 10 nanometer step. And then for the viewing angle condition, let's set theta at 10 degrees intervals and phi at 15 degrees intervals. So, I have defined the stack list and checked properties of all layers. And let's set the calculation method. TechWiz LCD offers both vector and tensor methods. Commonly, the vector method is widely used due to the fast calculation speed. Vector method is used when calculating the LCD mode such as TN, IPS, FFS, and VA modes. On the other hand, tensor method should be used when analyzing the OCB mode. This example is TN, so let's select vector. And you can select the optical analysis method. There are 3 types: extended Jones, Mueller, and Berman. Extended Jones matrix method is 2x2 solving method. The calculation speed is faster than any other method. Extended Jones matrix method and Mueller matrix method is the same. As you can see this figure, both extended Jones matrix method and Mueller matrix method cannot consider the multi-reflection inside of a material. However, Berman can consider the multi-reflection. Berman method supports 3 types: non-reflection, reflection, and apodizing. Non only considers BLU and multi-reflection, and the reflection option considers BLU and external light. It means that this option can represent the surface reflection. Lastly, reflection and apodizing can eliminate the severe ripple so that you can identify more clear optical result. In other words, this is an optical filtering technique, so it allows you to analyze the data correctly. And in this example, to calculate the simulation fast, let's use the extended Jones matrix method. So, all simulation conditions are set. Please save this file. And to start this simulation, please click this Run button. In the Confirm Variable List window shows the all conditions that we define. If it is OK, please click this Continue button.